Hi everyone, in this video we are going to investigate the fundamental differences between a cation and an anion. So just to review, both cations and anions are both ions, it's just that a cation has a positive charge and an anion has a negative charge. So just to review, cation is an ion with a positive charge, whereas an anion, leave yourself some space here, an anion is an ion with a negative charge. So there's three different things that I want you to just be able to identify very, very quickly whenever I say a cation or an anion. The first thing is, where are they located usually on the periodic table? And so the cations are usually on the left side of the periodic table. They are usually metals. And the last thing is that they usually have very low electronegativity. Okay, so cations have the positive charge, they're usually on the left side of the periodic table, they're usually metals, and they usually have low electronegativity values. So they're usually not fully attracted. The electrons are not fully coming toward them, okay? They don't have an attraction for that. Now, number one for an anion is that usually anions are located on the right side of the periodic table. They are usually considered to be your nonmetals, not always, but usually. And then they usually have higher electronegativity values than their corresponding cation, okay? So this is the fundamental differences between a cation and an anion. So let's go through a couple examples here and see if we can actually slowly start to kind of learn how to identify these in a quick manner, okay? That's all about speed. So now, will nitrogen be more likely to become a cation or anion? Go. Did you get an answer? Hopefully you did, and the way you approach this question is you just go through the three things I just talked about. So you look at your atom, which is nitrogen, and you say, okay, is it on the right or the left side of the periodic table? Definitely the right, so we're leaning toward the anion. Now, is nitrogen a metal or a nonmetal? Definitely a nonmetal. Good chance it's going to become an anion. And then, does nitrogen have a high or low electronegativity value? Well, we know it's tied in third place for the highest electronegativity value, so nitrogen is definitely going to become an anion. And so that's just a very, very quick way you can look at something and hopefully immediately be able to say cation or anion. Now, what we want to do is be able to determine the net charge of these species. And so I'm going to draw out nitrogen here, and we know nitrogen typically has 5 valence electrons. So I'm going to put one together in a lone pair and then 3 electrons. So this is going to be the neutral nitrogen atom. So I'm just going to write nitrogen. I'm going to put a 0 here, but that's usually not very common, but this is just to make sure that we're all on the same page. Now, alternatively, we could draw nitrogen out with an additional electron. So 1, 2, 3, 4, 5, and 6. So now I've added an electron, so this would be nitrogen minus, or the anion version of nitrogen. Now, on the other side, I could remove an electron. So instead of having 5 electrons, we only have 4. So this would be nitrogen plus. But how do we actually justify where that charge comes from and the actual number comes from? If I were to ask you to do that, give me a full breakdown of that number, what I would expect is that you would look at the atom as a whole. So you look at its full nucleus and everything around it. So what I'm saying is you have to look at all the protons and all the electrons. You cannot just look at the valence electrons. So let's start with nitrogen here at the center. We know when we look at our periodic table that nitrogen has 7 protons. Okay, it has an atomic number of 7. So that's going to be the case for all 3 of these, regardless of the charge, okay? So 7 protons each time. Now, we are saying that it has 5 valence electrons plus the 2 from the first shell, so it has a total of 7 electrons here. So now 7 minus 7 gives me an overall charge of 0. Okay, pretty straightforward. Now for this one, we're saying instead of the 7 electrons that it came here with, now we're saying we've added an electron to it, so it definitely has 8 electrons. And so now if we do a charge or a difference of this, we subtract it out, 7 minus 8 definitely gives us an overall charge of minus 1, right? So all of my protons are canceled out by 7 electrons, and I'm left over with an additional electron hanging around, giving us an overall charge of minus 1. Same thing with our cation here. So instead of having 7 electrons, we know we've lost an electron, and so we have now 6 electrons total. And so 7 minus 6 gives us an overall charge of plus 1. So this would be called your net charge. All right, and this is what I would expect you to be able to do if I asked you, where does that number actually come from? What is the minus, what does the plus mean? Well, it's the difference of the total number of protons inside the nucleus and the total number of electrons on the outside that are orbiting around. Okay, so we have to make sure we keep that clear. So here's my question. What is the net charge of, I'm just going to draw it for you. That's lithium with two valence electrons. Go. Did you get an answer? Hopefully you did. So the first thing you would have to do is figure out how many protons lithium has. Well, if you look at the periodic table, we see that lithium has an atomic number of 3. So it has 3 protons. And then we know from the first shell that there's 2 electrons, and then we see that it has 2 valence electrons, so 2 plus 2 gives me an overall charge of, overall total of 4 electrons. So if we do our net charge, 3 minus 4 gives me an overall charge of minus 1. So this lithium drawn this way would actually be written as lithium minus, or lithium minus 1. So here's my question for what we just solved for. Is Lm minus, so lithium minus, likely to form? Go. Did you get an answer? Hopefully you did, but if you didn't, that's okay. The first thing I'd want you to do is to identify your atom, which is lithium. So then you go through the checklist when we have the 3 different properties. Is lithium on the left or right side of the periodic table? Left, so we're leaning towards the cation. Is lithium a metal or a non-metal? Definitely a metal, leaning toward a cation. Last one, does lithium have high or low electronegativity value? Definitely low electronegativity, definitely more likely to be a cation. So is lithium minus or lithium anion likely to form? No, absolutely not. There is no reason why that would happen. Some kind of weird energy situation would have had to have occurred in order to force an electron onto lithium like that. So now we know that the one that actually wants to form is the cation, which is lithium plus. So here's my next question. How many total electrons are on lithium plus? Go. All right, did you get an answer? Hopefully you did, and the answer is definitely 2. If we have a lithium cation, it's because it's lost one of its electrons. It usually has 3 electrons, it's lost 1, so it only has 2. Now, the thing that I want you to kind of leave this video with and thinking about is, why does this happen? Why does lithium actually want to become a cation? Well, it all has to do with stability. So we know when lithium comes together and we can force it to, we can remove an electron off of lithium, it can create lithium plus, which means it only has its inner shell of electrons. It no longer has that single electron that's just floating around on the outer shell. So lithium plus is much more stable than just regular old lithium. And so it would much rather be a cation and be in that positive 1 state. We can also talk about this from the opposite end of the spectrum, which is fluorine. So fluorine, we know, is 1 electron away from having that full octet shell, full 8 electrons around. So fluorine would much rather gain an electron than lose an electron, because then it becomes fluorine minus. Fluorine minus has a full 8 electrons, so it's a full shell. So it is much more stable than regular old fluorine. So this has a full shell, and this has a full shell. Okay, so if you can somehow find a way to complete that octet rule by either adding or removing an electron, that is definitely the way to go. Take care of yourselves and drink water.